So greetings once again. So earlier on we did the videos about I explained the definition of a function, and now we're focusing on parabolic function or a quadratic function. So it's one and the same thing. You can call it a parabolic function or a quadratic function. So now earlier I did on about what is the definition of a function. So I think we understood the definition of a function very well. So this one we are going to focus on the parabolic function, because earlier we did about the linear function and the range of a linear function. So let's go to grade 10's parabolic function. So in grade 10, on this video, we are going to be looking at the real life examples, the intercepts, the drawing, how we draw our quadratic function, domain, how we write our domain and range. So this is what we are going to focus on. So let's go. So now, what is a parabolic function or what is a quadratic function? So you can see up there that Tommy is confused about what is a quadratic function, because the question is asked in class that what is a quadratic function, and Tommy is like, oh, what the hell is that? It's for the first time I hear about that. No, there is no need to be confused, Tommy. Now let's go back there to definition of a quadratic function. So the quadratic function is a relationship between the input value x and the output value y. So you remember that when we are talking about the relationship between the input value x and the output value y, we are talking about the function as well. So now, specifically, where the input x is raised, you can see that now it's starting to be specific. Where the input x is raised to the second power to give the output value. So it means that our input x value, remember that we said function is like something like this. So when we say that the input value x is raised to the second power, it means that is x squared. You see, that is x squared. Because what does it mean about the quad? The quad simply means that when you see a quad, it simply means about a square. So when we see a quad, we are talking about something like a square, because like when you see a quad, you see maybe four corners or four sides. So when you see four sides, first thing that should come to your mind is a square. So when you think a square is a power of 2. When you say a square, it's a power of 2. So that is why now we say that this is x squared. So that is why we say when you see a quadratic function, you must say that is x squared. So there's no a quadratic function that we can find where it has the power of 3. There's no way. So there is no a function that is called a quadratic function that has a power of 3, or they have a power of 2. I hope you understood what we are talking about when we are talking about the parabolic or a quadratic function. So now we are going to look at the real life examples on what is a quadratic function, what does it look like, and what it really does on the real life example. So here you find that we have a bridge. This a bridge in America. I don't remember very well about it. Is said that is something like maybe a red gate or gold gate. I don't remember very well, but it's a bridge in America. I took a certain bridge in America so that I can show you what the relevancy of this bridge. So the engineers, when they built this bridge, they used the same thing. They used parabolic function. They used the power of 2. They used the same formula that we are using when you do your bridge. So they did the same thing, because they also did mathematics, so they used the same formula when they built the bridge. So the reason why some of them they are like this, some of them they are frowned like this, some of them you can see if the shape is something like smiling, and you can see that this is something like frown shape. So there is a difference between these shapes, and their difference is caused by the parameter a. So if you write down our formula, you will understand what does a parameter a make to our graph. So now we are going back. You are going there. Don't be confused. We are going there. Just focus on this one. So now integrating quadratic equation, we are going to find something like find the y is equal to ax squared plus bx plus c. So now, if you look very well in the videos earlier, we looked at this thing. called C, and the C doesn't change. It doesn't matter what type of graph, it doesn't matter whatever type of graph, it doesn't change. It is always going to be the y-intercept. It doesn't change. This one doesn't change. It's going to be the y-intercept. So now we have new things here. We have B and the A. So what does A do to our graph? Now the A, what it does to our graph is just that it gives us the shape of the graph. It gives us the shape of the graph. It's not the gradient because it's in front of x. Most of the people, they tend it to be a gradient. Is not a gradient. A is not a gradient, guys. Make sure that you master this one. A is not a gradient, but it gives you the shape of the graph. Yes. So now, because you saw in the videos earlier on, because we had this kind of graphs, we had this kind of graphs earlier. I showed you this kind of graphs earlier on. You saw about the shape of a frown shape and the smiling shape. So now this is how A affects them. So when you see A, most of the time, you can see where A is placed. You can see where A is placed. When you see A most of the time, when it is greater than 0, it means that A is positive. When A is positive, when A is positive, and when A is less than 0, it means that A is negative. Now let me explain this. So when you see that A is greater than 0, or whenever A is positive, what do I mean when I say where A is positive? When A is any number that is greater than 0, any number that is greater than 0, you understand? 1, 2, 3, 4, 5, 99, 100, and those kind of numbers. So when A is greater than 0, it really means that your graph always is going to be shaped like this. Your graph will always be smiling graph. So in math, this is called concave up. Your graph is concave up. It means your graph is concave up. So whenever A is greater than 0, it means your graph is concave up. So for whenever A is less than 0, it means your graph now will be a frown graph. It is Z. You can see my graph is Z. So when you see my graph that is Z now, it means that my graph now changes, because now it was concave up. Now it will be concave down. So you see, whenever A is less than 0, it means that A is any number that is less than 0. So A is equal to -1, -2, -7, -50, -3/1. Those kind of things. Negative, as long as it is negative up to -infinity, it means your graph will always be a concave down. So whenever your A is greater than 0, or whenever A is positive, it means your graph will always be concave up. Simply what our A does to our graph. So now, your B is the one that determines the factors of your graph. Is the one that determines the factors of your graph. You will understand it very better when we are doing when we are plotting the graph and when we are giving the examples of a graph. So my example to you is 3/2x² plus 4x plus 2. So this is my example to you as a grid 10 for a grid 10 equation. So now we are going to realize what is our function. So this our function. The example that I gave you is function. So we are going to plot a function. We are going to do the intercept. So firstly, let's start by saying, now you realize what do we have here. Firstly, you say you have A is equal to, you see in the place of A, we placed 3/2. You can see, don't be confused. In the place of A, we placed 3/2. In the place of B, we placed 4. In the place of C, which is the y-intercept, we have placed what? 2. It means you already know about two things that I already taught you now. So things that we spoken about, it was about A, and it was about 2. So Now when you see A, it means that you start realizing, what does A mean? When I see A, it means that it determines the shape of my graph. So how does it determine the shape of the graph? So in order for it to mean the determined shape of the graph, it must be less or greater than 0. So let us see now. Is our A greater or less than 0? So our A is 3 over 2, which is greater than 0. Oh, I'm sorry to say this. Our A is greater than 0. It means our graph is going to be shaped like this. Is the first statement that you know, this one. So now, there is C, where C is equal to 2, which is the y-intercept. So now, when you see C as the y-intercept, it means that whenever we see C, it means that it is where our graph cuts the y-axis. It where our graph cuts the y-axis. So let us draw our Cartesian plane. That is our Cartesian plane, you see. That is our Cartesian plane. So now, let us go and see what is going on. We say that at 2, at 2, 2 is somewhere here. It is where our graph cuts the y-axis. You see this our y-axis and this our x-axis. So this is the place where our graph cuts the y-axis. So it means it must be shaped like this, or maybe it will shape like this. We don't know whether it's down here or it's up, or it's up here. We don't know whether it's down or up here. We're going to plot the graph now.